Bonding a fiberglass hydromassage tub involves several steps to ensure electrical safety. Firstly, you need to connect to the motor ground terminal. Locate the grounding terminal on the motor. This might be a green screw or a green wire nut. Connect the number 8 solid wire to this grounding terminal using a ring terminal and ensure the connection is tightened securely. Secondly, bond the tub itself. Run the number 8 wire from the motor grounding terminal around the perimeter of the tub. Use plastic cable ties or clamps to secure the wire to the tub every 4 to 6 feet. While doing this, avoid touching any metal parts or plumbing fixtures. Thirdly, you have two options for connecting to the house grounding system. Option 1 is a direct connection. If your house grounding system has a dedicated grounding rod, connect the number 8 wire directly to the rod using a clamp. Option 2 involves a connection to the electrical panel. If there is no dedicated grounding rod, connect the number 8 wire to the grounding screw or bus bar in your electrical panel. It is crucial to understand that the number 8 solid wire must be connected to the grounding terminal on the motor and not to the number 12 ground wire of the motor. The number 12 ground wire is used to protect the electrical circuit, while the number 8 wire is used to bond the tub and ensure overall safety. Adhere to these safety precautions. Always turn off all power to the tub before performing any electrical work. Use only approved wiring materials and strictly follow all electrical codes. It is also highly recommended to have any electrical work inspected by a qualified electrician to guarantee safety and compliance. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electric shock. The number 8 bonding wire must be connected correctly to the motor's grounding terminal, and the connection should be mechanically sound and electrically conductive. Make sure the ring terminal used is appropriately sized for the screw or bolt on the motor's grounding terminal. When running the bonding wire around the perimeter of the tub, avoid sharp bends or kinks in the wire. These can create stress points and potentially compromise the integrity of the bonding connection. Use cable ties or clamps that are designed for electrical applications, ensuring they are resistant to corrosion and environmental factors. When connecting to the house grounding system, whether it's to a grounding rod or the electrical panel's grounding bus, ensure the connection is secure and meets local electrical code requirements. Use appropriate clamps or connectors that are listed for grounding purposes. The purpose of the number 8 bonding wire is to provide a low impedance path for fault current, allowing the circuit breaker to trip quickly in the event of a fault. This reduces the risk of electric shock and minimizes potential damage to the equipment. The grounding system in your house should be properly installed and maintained. If you are unsure about the integrity of your grounding system, have it inspected by a qualified electrician. The electrical panel's grounding bus should be securely connected to a grounding electrode system, which typically includes a grounding rod or connection to the metal water pipe. Ensure that all connections are tight and free from corrosion. In some cases, additional bonding may be required for other metallic parts near the hydromassage tub, such as metal water pipes or metal enclosures. Consult with a qualified electrician to determine if additional bonding is necessary to meet local code requirements. Always refer to the latest edition of the National Electrical Code, or NEC, for specific requirements related to bonding and grounding of hydromassage tubs. Local codes may also have additional requirements, so it's important to check with your local building department or electrical inspector. Proper grounding and bonding are essential for electrical safety. Do not attempt to perform any electrical work if you are not qualified or comfortable doing so. Always seek the assistance of a licensed electrician who has the knowledge and experience to ensure the work is done safely and correctly. Failure to properly ground and bond a hydromassage tub can create a serious safety hazard, potentially leading to electric shock or even electrocution. Take the necessary precautions and consult with a qualified professional to ensure the safety of yourself and your family. Bonding also helps to reduce electromagnetic interference, or EMI, which can affect the operation of electronic equipment. By providing a low impedance path for fault current, bonding minimizes the potential for voltage differences between different parts of the electrical system. This can improve the performance and reliability of sensitive electronic devices. The size of the bonding wire, number 8 in this case, is determined by the size of the overcurrent protection device, such as a circuit breaker or fuse, that protects the circuit. The NEC specifies the minimum size of the bonding wire based on the ampere rating of the overcurrent protection device. Ensure that the bonding wire is properly supported and protected from physical damage. Avoid running the bonding wire in areas where it could be easily damaged or subjected to excessive stress. If the bonding wire needs to be run through a wall or other structure, use a conduit or other protective sleeve to protect it from damage. Periodically inspect the bonding connections to ensure they are still tight and free from corrosion. Over time, connections can loosen or corrode, which can compromise the integrity of the bonding system. If you notice any signs of corrosion or loose connections, clean and tighten the connections as needed. When working with electrical wiring, always use appropriate safety equipment such as insulated gloves and safety glasses. These will help protect you from electric shock and other potential hazards. Be aware of the potential hazards associated with working around electricity. Never work on electrical equipment while standing in water or on a wet surface. Always keep your hands dry and avoid touching any bare wires or terminals. If you are unsure about any aspect of the electrical work, stop and consult with a qualified electrician. It's always better to be safe than sorry when dealing with electricity. Bonding is not the same as grounding, although the two terms are often used interchangeably. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting different metallic parts of the electrical system together. Both grounding and bonding are important for electrical safety, but they serve different purposes. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and de-energize the circuit. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electric shock. The grounding electrode system typically consists of a grounding rod, a metal water pipe, or a combination of both. The grounding electrode system should be properly installed and maintained to ensure it provides a low impedance path to ground. The grounding conductor, which connects the electrical system to the grounding electrode system, should be sized according to the NEC requirements. The grounding conductor should be protected from physical damage and corrosion. If you are replacing a hydromassage tub, make sure to properly disconnect the old tub and remove all electrical wiring before installing the new tub. Follow the manufacturer's instructions for installing the new tub, including all electrical connections. If you are unsure about any aspect of the installation, consult with a qualified electrician. When connecting the number 8 bonding wire to the electrical panel's grounding bus, make sure to use a listed connector that is designed for grounding purposes. The connector should be properly sized for the number 8 wire and should provide a secure and reliable connection. Avoid using wire nuts or other non-listed connectors for grounding connection. Wire nuts are not designed to provide a low impedance path for fault current and can create a safety hazard. The grounding bus in the electrical panel should be properly sized to accommodate all of the grounding conductors and bonding wires that are connected to it. If the grounding bus is too small, it can become overloaded and create a safety hazard. If you are adding additional circuits to the electrical panel, make sure to upgrade the grounding bus if necessary. The NEC specifies the minimum size of the grounding bus based on the size of the electrical panel and the number of circuits that are connected to it. When running the number 8 bonding wire, avoid running it parallel to power conductors for long distances. This can create inductive coupling, which can induce voltage on the bonding wire. If it is necessary to run the bonding wire parallel to power conductors, keep the distance between the two as short as possible. Inductive coupling can also be reduced by twisting the bonding wire with the power conductors. This will help to cancel out the magnetic fields that are created by the power conductors. The number 8 bonding wire should be installed in a neat and workmanlike manner. Avoid creating unnecessary loops or kinks in the wire. The wire should be properly supported and protected from physical damage. If the wire needs to be run through a conduit or other raceway, make sure to use a conduit or raceway that is sized appropriately for the wire. The conduit or raceway should be properly supported and secured. When making connections to the grounding system, use antioxidant compound on all bare metal surfaces. This will help to prevent corrosion and ensure a good electrical connection. Antioxidant compound is especially important in damp or corrosive environments. Apply the antioxidant compound liberally to all bare metal surfaces before making the connection. When tightening the connections, use the proper torque settings. Over-tightening the connections can damage the conductors or connectors. Under-tightening the connections can result in a loose connection, which can create a safety hazard. Use a torque wrench to ensure that the connections are tightened to the proper torque settings. If you are working on an older electrical system, be aware that the wiring may not be up to current code standards. Older wiring may be undersized or may not have a proper grounding system. If you are unsure about the condition of the wiring, consult with a qualified electrician. It may be necessary to upgrade the wiring to meet current code standards. When working on electrical systems, always be aware of your surroundings. Keep children and pets away from the work area. Avoid working in areas where there is a risk of falling or tripping. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are working in a confined space, make sure there is adequate ventilation. Confined spaces can contain hazardous gases or fumes. When working on electrical systems, it is important to stay focused and alert. Avoid distractions, such as talking on the phone or listening to music. If you are feeling tired or stressed, take a break. It is better to be safe than sorry when dealing with electricity. The NEC requires that all electrical equipment be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Listed equipment has been tested and certified to meet certain safety standards. Make sure that all of the electrical equipment that you are using is listed by a recognized testing laboratory. Listed equipment will have a label or marking that indicates that it has been tested and certified. If you are using electrical equipment that is not listed, it may not be safe to use. Non-listed equipment may not meet the required safety standards and could pose a fire or shock hazard. When installing electrical equipment, follow the manufacturer's instructions carefully. The manufacturer's instructions will provide important information about how to install the equipment safely and correctly. If you do not follow the manufacturer's instructions, you could damage the equipment or create a safety hazard. The NEC requires that all electrical installations be inspected by a qualified electrical inspector. The electrical inspector will verify that the installation meets all applicable code requirements. If the installation does not meet code requirements, the inspector will require that the necessary corrections be made. Do not attempt to conceal any electrical work from the inspector. Concealing electrical work can create a safety hazard and could result in a fine or other penalty. Always cooperate with the electrical inspector and make any necessary corrections promptly. The NEC is updated every 3 years. It is important to stay up to date on the latest code requirements. You can purchase a copy of the NEC from the National Fire Protection Association or NFPA. You can also find information about the NEC on the NFPA website. Many local jurisdictions also have their own electrical codes. These local codes may be more stringent than the NEC. It is important to check with your local building department to determine the applicable electrical codes in your area. If you are unsure about any aspect of electrical work, consult with a qualified electrician. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and correctly. Hiring a qualified electrician can save you time and money in the long run. It can also protect you and your family from potential electrical hazards. When choosing an electrician, make sure to check their qualifications and experience. Ask for references and check their license status. Make sure that the electrician is properly insured. A qualified electrician will be able to answer all of your questions and address any concerns that you may have. They will also be able to provide you with a written estimate for the work. Get multiple estimates from different electricians before making a decision. Bonding is a critical aspect of electrical safety and must be performed correctly to protect against electrical shock.